today for this event of Mantova Architettura. It's a pleasure for us that you are here for this lecture. I bring you the greetings from the Prorector of Mantova, Federico Bucci, and we are really happy we can share some of your experience with the students today and in the context of Mantova Architettura. Just for a brief presentation, Ilka Ruby is a Berlin-based publisher and curator that together with their partner Andreas Ruby founded TextBuild, an office for architectural communication, and Ruby Press, a publishing house with focus on architecture and other cultural practices engaged in the production of space. Ilka Ruby has realized a number of exhibitions as well, such as the exhibition Droit, Lacaton et Vassal, Turbois et Prêtre for the German Architecture Museum in Frankfurt in 2012, and Treasures in Disguise, the pavilion representing Montenegro at the 14th Architecture Biennale in Venice. And she taught at Cornell University, Berlin University of Arts, and the Peter Behrens School of Architecture in Düsseldorf. So thank you again for coming. The keywords of this lecture will be many, but we will talk about the maintain, reuse, the capital of building, of existing buildings, the possibility of a circular economy in architecture, and the possibility of creating with architecture another raw material, another resource that can be put into circulation instead of producing waste. So of course, as we know, there is the necessity of building, but the approach that the architect have in the construction of the built environment can differ a lot. So what we ask Ilka to speak about is exactly what kind of approach an architect can have in these terms to manage to define a sustainable future and sustainable action for the future. Thank you very much. So I give you the word.
So the lecture is titled Enough is Enough, and this is also the title of an exhibition I did together with Anka Tjurek and Brindusha Tudor for the Better 2020, the Timisoara Architecture Biennial last year. And we face many challenges today, and most obviously climate change, but also migration, the abuse of big data, the drifting apart of our society, and now on top of all that, also a pandemic. But of course, there's also something positive about that pandemic, because it is proof that radical change is possible. So with almost no time, we were able to transfer our work in schools to our homes. We made incredible progress using digital tools, like we do this digital lecture here now, we stayed productive and connected by these tools with our families and friends. And the pandemic also taught us that it's helpful that we and our politicians listen to scientists rather than business representatives. And that in the end, this will pay off for all. Because after all, we cannot fight nature. Even our economy will need to be a sustainable one if it wants to survive. So although we are in this terrible situation now, all this also gives hope that our ecological crisis can be prevented by radical measures. If we, as a society and our political leaders, take the necessary actions. An architect can make a huge difference to all these challenges I listed before. But the biggest impact architects and designers and urban planners can make is on the environment. So the construction industry consumes half of all resources extracted from the earth, and it is responsible for more than a third of global energy use and emissions. And cement production alone produces roughly 7% of global CO2. So there's a lot architects can do if they change the way they build, and they approach design and construction. And the title of this lecture, Enough is Enough, means, first of all, that we had enough of business as usual, that it's time to change the way we design and build, but it also means enough is enough, and that we can make do with what we have. And we structured the exhibition by 9 claims we made. We think that are crucial for responsible architecture. And in this lecture, I will show one example per claim. So let's start with the first. Do we really have to build? There are roughly 1 million animal and plant species are approaching extinction. This is more than ever before in human history. And the #1 driver of change is shifts in land use and sea use. Urban areas have more than doubled since 1992, and 5 million kilometers of new paved roads are likely to be built by 2050. That means the work of planners, architects, and engineers will have a massive impact on that development and its effect on our planet. So every project should start with the question, do we really have to build? And no should always considered an acceptable answer. And the project I want to show is by La Vassal, a place in Bordeaux. The architects were asked to make a proposal for a competition to embellish this plaza, just to make it nicer. And they participated in this competition, and they went there and spoke to people, spent some time there. And their conclusion was the place is already beautiful. It doesn't need anything more. Then nothing has to be built there. The only thing that could be changed is a bit of maintenance. And so in their proposal, they said, well, we don't build anything, but you can maintain the plaza a little bit better. You can clean it from these drops that come from the trees and these kind of measurements. So I think it's a very powerful example that architects not only have to build, and it also showed the way they approached the project. It's already our second claim, which is mapping local resources. So there's no tabula rasa in any project. When we start design, we work within a context that provides us with resources, both tangible and intangible. So like La Vassal went there and looked very carefully of what was already there. They came up with their solution for the plaza. And this is what every project should do first. Using locally sourced material can also deliver social and economic benefits, reduce emissions and transportation costs, and support local industries. And to gather information about our surroundings, we can team up with experts from fields such as biology, geology, geography, and sociology. And a project that did this in a very impressive way is the Skanderbeg Square in Tirana. This is how the space looked before. It was mainly a plaza for cars. Huge area in the middle of the capital of Albania. And this is how it looks now when you approach it, the plaza from its edges. So there's, when you see here in the plan, there is a green belt that surrounds the plaza, and this green belt creates some kind of filter between this kind of dense and chaotic city and this really huge open plaza in the middle, which is here marked as this square. And this green belt consists out of a huge variety of plants that are from Albania or used to be from Albania, but many of them don't exist in Albania anymore and had to be re-imported. So the architects made a huge survey of these kind of plants that could be used, a catalog, and re-imported some of those plants, so to give them again a home in Albania. They made this kind of really detailed planting plan, with every plan with this kind of table where you see for every plant how much water does it use, how much are the roots, how big are the roots, how tall is this plant growing, and so on, with all the properties of the plants. And then they work together with with local communities and adjacent users of the buildings to create a kind of programming of these different gardens they created, so that the functions of the buildings can also spill out into this green belt, into the plaza. So you have a lot of different atmospheres that are in these gardens surrounding this kind of big plaza. And what it also did was, of course, that these plants and gardens, they kind of combined, and these buildings that were scattered around the plaza from the communist, most of them from the communist area, very kind of monumental buildings. You see also these kind of water puddles on the plaza. So there's an underground system of fountains. And what is very important is that this plaza in the middle, this is not just a plain square, but it is a pyramid. It's a pyramid, a very, very flat pyramid of 177 by 157 meters. So it's really huge. And why is it a pyramid? You see here the section, and in the upper section, it's half the pyramid. So you see on the left where this kind of person is standing, this is the tip of the pyramid. And once you're on this tip of the pyramid, you're more or less on eye level with these huge buildings surrounding the plaza. So all these buildings were on monumental pedestals built. So when you're standing in front of them, you look very small, and they look very monumental. And by providing these kind of very shallow pyramid, you will be able to see these buildings on eye level. And the lower section shows the whole plaza. You see, there's also an underground parking included. These are these underground fountains, and these fountains make these very nice patterns on the plaza. You see the colors of these stones, but it also, of course, creates some kind of microclimate. It's a very hot place, so it cools the place, and of course, it's also fun for kids to play with the water. When you look at these, the ground and the stones, this is also very interesting, because these are different stones from all over Albania, and they were used here on that plaza. So the architect made a process where they were looking what kind of local stones are available in the country, what are the properties, what are the colors, and so they brought together all those stones with these kind of very different structures and colors, and they created this pattern, these shading patterns. So when you see to the right the pyramid, you see that it's from the left bottom corner, it's more the reddish colors, and opposite the right upper corner, it's more the greenish colors. So you have this very, very subtle shading in the end. Yeah, and this makes this really amazing plaza. Of course, there's much more to tell about this project, but I will only focus on the aspects related to the claims we made. Reusing what is abandoned is the next claim we made. The decline of industry has resulted in a vast abandoned built heritage. And although these buildings were constructed for very different purposes, they are often surprisingly flexible and can be adapted to contemporary needs. Protecting these structures and inventing new ways of inhabiting them is an important part of architecture today. And demolishing these buildings should be our last options. So if we consider them to be material and cultural resources that we can reuse and transform, we can also draw lessons for the design of new buildings that take adaptation into account from the beginning. But this approach of reusing does not only apply to buildings, it also applies to infrastructure. And an example for that is this river bath in Berlin by Realities United. So this is an example how an unused river arm of the River Spree in Berlin, that used to be just a street for boats, is turned into a public space for swimming and experiencing the river. And at the same time, it's also a project that cleans the river. And this it's a very old project, one can say. It's not yet realized, but it started already in the 1990s. And the first idea was born here. What we see here is an abandoned, never finished building, and in this kind of, let's say, basement of the building, which was that was used as a club and an office for the artist and architect group Kunst und Technik at that point. And they made these parties, and these parties happened to be where the red arrow is. There was the building. It was directly at this River Spree. And the architects thought, oh, wouldn't it be great if we could swim in the river? Because swimming in the river is not allowed, not because it's too dangerous, but because the water quality is not good enough. We have this kind of system in Berlin, which is called a mixed sewage system. So whenever there's a lot of rain, also the rainwater and the gray water, they go together into the same sewage system. That means if it rains a lot, the sewage system is too small and cannot take in all the water. So everything that is, it overflows into it flows into the river. And then the river, of course, is polluted, the fish die and so on. So that's the reason why it's not allowed to swim here in the river, because it's not safe because of pollution. The architects from Kunst und Technik, two of the architects, Jan and Tim Edler, later founded Realities United, and they pursued this project, this idea they had from the very beginning. And today, this project is supported by VASE political majority, and there's an association called NGO that is called Flussbad. This is also now pursuing the project, and it was able to acquire more than 6 million euros of public funding for its implementation. So what is it exactly? We see here the River Spree, it kind of divides, and there are these two arms. And what you see in the middle is the Museum Island with all the it's the historic center of Berlin with all these kind of very famous and museums, like the Bode Museum and this kind of newly built palace we have, which is now the Humboldt Forum. And you see all these kind of very famous buildings. And it's a very touristic part in the city, not very much used by locals at all. So and what the project wants to do is say, okay, this one arm, the lower part, is not used for ships anymore. It's really an unused or underused space. And we can use this and turn it into a public space. And we do this by using 3 different areas. So the first area would be a semi-natural waterway. Then there would be a filter area that cleans the water. The filter area is made out of reed bed filter, gravel and sand and reed. And then once the water is cleaned, it flows into the swimming area, and it produces this more than 800 6-meter long swimming area. Which is totally public, without any entrance fee, without any lifeguard, and it gives access to the river before it combines again with the other arm of the river, close to where the arrow is. So I will lead you through all these 3 parts. Though this would be the semi-natural part. Before, this was just a kind of, a stone canal. I mean, it still is a stone canal because the project is not yet implemented. But so this first part would be kind of a natural environment where you have the possibility to go down to the water, and you have this kind of park, adjacent park to it, and this walkway. This is the section for it. And then if you go further, you come to this kind of filter area. This would look like this. So it's really reed and sand and gravel, and the water, by flowing through this, the water gets clean. And it flows into this bathing area, the pool, and there are little, just minor adjustments with stairs that make it possible to go down to the water, with some kind of changing rooms where you can change and where you can store your stuff. That would be now the last part of the swimming pool. That looks like this. So you could experience this kind of historic or new historic, as we see here, a new historic city center from the water. Here you see again the huge part this project would occupy, turning it into a public space again. And it's not yet realized, but what is realized is, for example, this kind of boat where the Flussbad people set up a testing facility for water filtration. And also the green area behind, under the trees, is an open air exhibition where you can learn about the project, about water, about the Spree, and also where it's a place where events take place, where you can learn about this stuff. So here you see how the water is being cleaned and tested. And what also happens is that once a year, there is a swimming cup, where you can already test swimming in the river. And you see here, it's done a couple of, of course, last year it had to be cancelled because of the pandemic, and also 2019 and 2017 it had to be cancelled because the water quality was not good enough. So before they do this kind of cup, swimming cup, they have to test, of course, is the water clean enough, and a couple of times it wasn't, but all the green numbers indicate the years when it was possible to swim. And this is how it looks. Then you have to register for it, and then you're allowed to take, to be part of this competition and swim the part of this river. And it looks like this. Yeah, and here again you see all the existing river baths in Berlin. So they are more towards the edges of the city, but the Flussbad project would be really in the center of the city. So it would be really a crucial change for experiencing a leisure facility for people living in the city. Next claim is repairing what is broken. So the most sustainable building is the one that never gets demolished, since its materials never turn into waste and no additional emissions will be produced in erecting replacement. So that means we must invest time and resources in repairs so that every structure can reach its maximum lifespan and new ones don't need to be built. Maintenance is a craft in itself and must be considered as an integral part of the design process. which can generate important features of the architecture. Besides designing for durability, anticipating the aging of a building also means creating projects that can transform or grow or shrink. Example for this way of designing is the transformation of 530 units in Cité du Grand Parc in Bordeaux by Lacroix-Massal, Frédéric Drouot, and Christophe Routin. So here you see the before and the after of the building. So it's these three large building slabs from the 60s, 70s that were in very bad condition. But instead of demolishing them, they were transformed. And they were transformed in a way because they were not empty. They were fully occupied, and they were transformed in a way so that the people who lived there could stay there. This is how it looked after the transformation. Here you see the from inside, the before and the after. So what was done? It was transformed by taking away parts of the existing facade and replacing it with a winter garden and balcony. You see here on the lower part, there are already these kind of platforms for the winter gardens. This was built first. And once this would also already kind of work as the scaffolding of transforming the building. So once this was built, this facade was taken away, and after the transformation, it would look like this. So you have a huge winter garden. The existing facade is replaced by these large sliding floor-to-ceiling glass sliding doors, and you have this winter garden, and on the left you see the sliding doors of the winter garden, which are these of this thin corrugated material, polycarbonate material, and the balcony in front of it. And by adding these curtains, this silverish curtains you see in the back, you can also protect from too much sun, and there are also curtains inside the existing building, behind these glass facade to the right, which help to insulate the building. These are thick thermal curtains. So something that looked like this before got kind of cut out. You see this temporary wall behind the opening to prevent dust going into the apartment, because as I said before, the apartment is still occupied. And then after the transformation, you have a space like this. Here you see the ground plan, and all the blue part is the newly added part of the winter garden and the balcony. So, and this winter garden is not only an additional space, an extra space the inhabitants can use, and by this enlarge their apartment. It also works as a buffer, thermal buffer, for because this is not heated. It's a not heated space, but of course it gains solar gains, passive solar gains, and by this it's a buffer, and it reduces the heating costs for the apartments. And these spaces are programmed by the inhabitants in very different ways. Here you see from inside to the outside, and these are the silver sun protection curtains you can close to keep the sun out if it's too hot. Recovering materials would be the next claim. When it comes time, I mean, usually you shouldn't demolish buildings, as we saw before with Lacroix-Massal, but when it comes time to demolish a building, nevertheless, we must learn to use its leftovers. Building elements can be stored, protected, repaired, and finally put back on the market. By reusing materials and components we already have, we can save resources and reduce waste. And to achieve this, we must understand architecture to be the design of processes rather than objects, and create buildings in a way that they can easily be disassembled, so all parts can be reused or recycled. That means, for example, avoiding component materials and specialized products that are difficult to recycle. So gluing materials together, for instance, makes it difficult to take them apart later. It's better to use screws, magnets, or Velcro even. And a project that does this kind of recycling and reusing of materials in a very impressive way is this neighborhood center Lüßbichel by Baubüro Infito in Basel. So this is the building. First of all, the building is also a conversion. It was, the building formerly housed a distribution center and an industrial bakery. And the architects of course, they said, okay, we will keep as much as possible of the existing building, but they did much more. So when we see the ground plan, they had to cut. It was a very deep building because it didn't need, distribution center didn't need light. But now, of course, it needs light. And so they had to cut this courtyard into the building. And also on the right, they had to shorten the building because the building regulations asked for this kind of passageway on the right. So this is the passageway that had to be there. And you see, by doing these kind of two interventions, the courtyard and these kind of passageway, there was a new facade necessary. 86 meter long and 10 meter height. And these two elements, the facade to the new courtyard and also the facade to the passageway, of course, they needed windows. So the architects collected 200 windows, and they did this because they asked window producers in a radius of about 100 kilometers if they had surplus production. That means windows that were produced too much, or they were produced not according to the order. And usually these windows are thrown away, but by this they could be saved and used for this building. Of course, these were the forms and sizes of these elements. So you had various window shapes and sizes, and they all had to be combined in a design in these kind of elements that could take in these kind of very different shapes and sizes. So these are wooden facade elements where these different windows can be integrated, and to kind of make it a little bit calmer, this kind of very wild window. You have these kind of green to the left and the right, these green metal sheets. These metal sheets, yeah, I'll come to this later. First, you saw these frames are made out of wood, and also this wood is recycled. The facade elements are constructed from 150 cubic meters of reused wood. The architects collected roof purlins that are usually burned after demolition of a building. And they collected this wood, and they were upgraded to glue laminated beams that meet the strict technical requirements for facades. So that was an upgrade of this kind of used material. And out of this beams, they built these elements, facade elements. And these elements were then filled with the windows, but also with insulation material. And these insulation materials are also leftover pieces of rock wool insulation that were collected from other construction sites. So usually this kind of leftovers are melted down again with a lot of energy and processed into a new product. But here these pieces were collected and inserted in this wooden frame, and whatever was kind of necessary to fill up was filled up with stone wool granulate. So this was all prefabricated in the workshop, as you can see here, and then brought to the construction site and assembled as the new facade. Now we come to this green metal cladding that was used in the existing building before, and it was reused directly. And in addition to this, there were also sheet metal cladding from another building only 50 meters away that wasn't used anymore. So they dismantled also this material and reused it in the this building here. Here you can see this part where this kind of beige and the green material meet. And this is the courtyard with all the different windows. And here you see it from the inside. To change from a linear to a circular economy, the availability of used building materials and components needs to be improved. Used materials should be as easy to acquire as new materials. This is of course not yet the case, but there are more and more people that deal with it, and I think this is something that really should be supported. Remembering crafts was our sixth claim. To reduce waste and emissions, we must rethink not only what we build, but also how we build. And in an increasingly digitized world, we must value the social importance of labor and manual fabrication. Looking beyond the boundaries of building as usual can reveal alternative construction techniques, materials, and typologies. And sometimes a look back into the rich history of techniques that have either been forgotten or deliberately suppressed in the name of progress can offer smart solutions. By rediscovering, learning from, and adapting methods that evolved over centuries, we can make smart use of local resources, both materials and human know-how. This project by Anna Heringer, Anandaloy building, is a very good example for that. It's in Bangladesh, and it's a center for the treatment for people with disabilities and a workshop. And often people with disabilities are seen as a kind of punishment from God or kind of bad karma for my life. And because of this, they are rather hidden than included. And places for therapy are very rare in the country and often not existing at all in rural areas such as this here. And in the beginning, the building was only planned as a therapy center. But then Anna Heringer and her team was able to expand the program of the building and include another story, hosting a workshop for the female tailors in the village. And the concept was not only to provide treatment for the people with disabilities, but also provide them with an opportunity to learn and work and engage in the community. So you see, the building has this huge ramp so that also people with disabilities are able to enter the first floor. Here we have the ground plan. It's very simple. So on the ground floor, you have this kind of therapy rooms, office, toilet, and on the upper floor you have a store and this tailoring workshop. And there was a lot of discussion. Why do we need this big ramp if the workshop is on the first floor and the therapy is only on the ground floor? But of course, it's about this kind of inclusive idea that to make every part of the project accessible for everyone. It was developed together with a local team and built with the local team. And you see here, it was built out of local materials, adobe and mud and bamboo. And both materials leave no waste after the building, if the building at some point gets demolished. So the bamboo is can degrade, and the mud just disappears, of course. You see here how the building is being built. So the walls are out of mud, and the roofs are made from bamboo. You see the therapy and learning spaces on the ground floor. The therapy spaces here. There are these, you might have seen in the ground floor, these kind of cave-like spaces where kids can hang out and hide and play. And you see the first floor with the access to the workshop where the women can work with the textiles, producing beautiful, first of all, also clothing, but also these kind of very beautiful things like this ground plan, stitched ground plan for an exhibition, for example. So we have seen mud and bamboo before, two very old building materials, but we also must research for new alternatives that follow a cradle-to-cradle design approach and products that are biodegradable or loop back into the cycles of production. Construction components can become packaging or agricultural nutrients, and industrial or agricultural byproducts can become building materials. And already known renewable materials such as wood, bamboo, and hemp can be exploited even further. To achieve this, architects must collaborate with biologists, ecologists, and chemists to cultivate new biomaterials made from fungi or bacteria. And I'll show you two examples of that from Dirk Hebel and the Kit Karlsruhe. So one deals with bamboo. We have seen bamboo before with Anna Heringer, and there the bamboo was used as it is, the trunks of the bamboo. But this can also be developed further. And we see here the natural habitat of bamboo. It's very big, and it's most of the countries of the developing world that have a huge need for building materials are within those habitat of bamboo. And bamboo is a very strong, very fast growing material. So it's really a great material to explore further. So instead of using the, let's say, trunks of the bamboo, you can, of course, develop it further. You can cut it and make panels and other parts out of it, other elements out of it, so that you can use it in way more, in other ways than we've seen before. And a lot of new applications are possible. These are two of the products that are developed. Bamboo is also really a strong material. We see here when you compare it to steel, it's even stronger than steel. And if you think that steel reinforced concrete is the most common building material in the world, and that developing countries use close to 90% of the cement and 80% of the steel consumed by the global construction sector, but that these countries, or very few of these countries, however, have the ability or resources to produce their own steel, bamboo could be a very interesting replacement for them, because then they could produce this by themselves and they are not dependent on the developed world. So, for example, out of 54 African nations, only 2 are producing steel. So all the others have to compete for steel on the global marketplace. And this is why here, this is research going on how, for example, bamboo could replace the reinforcement of concrete. And so this was the bamboo example. And another example is mycelium. What is mycelium? Simplified, one can say it's the roots of the mushrooms. It's a kind of extensive underground root network and normally remains invisible. And it grows very extensively and densely and homogeneously, and it represents the digestive system of the organism. And this can be used to grow building elements. In mycelium-bound building materials, the binding power that this root network provides us is used. And agricultural waste or waste from the wood and food industry can serve as food for the fungus for the growth process. And the mycelium network binds the organic substrate as it grows. This process can take place in specially made molds, so any geometry can be produced. And we see here some examples of compressed mycelium-bound materials. We have these panels or insulation material, as we see here in this wall. And this material combines several properties. So they have thermal and acoustic insulation, mechanical strength is comparable to those of polystyrene foams, up to of plywood. And of course, it also uses low energy during production, and it's biodegradable. And here we see the myco tree that was developed at the kit. And here it's used as a structural element. So there are these, so the mycelium was grown in these different elements, and these elements are then connected, as we see here, to this kind of structure. Caring for community would be the next claim. Because a responsible architecture is not only to take into account the ecology, but also the economical and the social aspects of a project. And over the past decade, we have witnessed a growing social movement fostering collectivity, sharing, and participation. In the wake of the global real estate and financial crisis, a new generation started seeking alternative ways of life based on sharing, and the idea that you have to own something in order to use it became obsolete. So why buy a car if you can share one? Or why pay for a hotel if you can swap flats? And this shift in social values can also be seen in architecture. Many grassroots initiatives are developing new models of co-ownership, co-production, and co-management. And the concept of the cooperative is experiencing a new renaissance. And the project I want to show as an example for that claim is La Borda Housing Cooperative by La Coll in Barcelona. It's a project initiated and self-organized by a neighborhood community who wanted to reclaim an abandoned industrial site and get access to decent, non-speculative housing based on its use value. And the cooperative of architects La Coll has been involved since the beginning of the neighborhood protests in 2012, driven by the motivation to build an alternative in a context of a serious housing crisis in Barcelona. So this is one of the standard ground plans of the building. It consists out of 28 private apartments they have 40, 60 or 75 square meters. But the project also consists out of a lot of collective spaces. We see here the ground plan. So there's this huge to the left. There's a huge kitchen, collective kitchen space and dining room. There are laundry rooms, there's a multi-purpose space, spaces for guests, healthcare spaces, storage spaces, and exterior and semi-exterior spaces such as the patio and the roof terrace. So this is the collective kitchen. And we see the section of the building with the kind of patio. And there's this big double height space to the right on the first floor. This is also collective space. And we see also the roof terrace to the right. This is the collective space with the laundry, which is used for many purposes. These are all the apartments have access from this kind of arcade surrounding the courtyard, which is also used as a balcony and makes a kind of transition space between the public and the private. You see here already a little bit of the roof, the covered roof, and this is the terrace. The roof can be opened and closed according to thermal needs. Here you see the winter and the summer, so that, of course, also the project makes use of the passive solar gains, so that the heating costs could be reduced too. Here, a view from one of the apartments towards the outside facade, and these balconies to the outside. And as you've seen before, the building is made from wood, also renewable building material. And this is how it looks from the outside. And this is how it looks from the other side, where you can see the double height collective space on the first floor. So this brings me already to the last claim, sharing knowledge. Maintaining a livable planet for future generations will require dramatic changes in the way we build and live. But a shift to a more responsible lifestyle can only succeed if gains are wide acceptance. Therefore, raising awareness and education are key when it comes to establishing new ideas and habits. Scientific knowledge and experience from best practices have to be easily available online for people in the field, and architects must communicate their ideas to policymakers and the public at large. This might be done via transdisciplinary networks of citizens and experts that bring together knowledge and lessons from a broad range of disciplines. And we should establish laboratories for collective and experimental learning, where people can get hands-on experience with new methods and materials that are developed. So as a last project, I will show you the floating university in Berlin by Ramblabor. The site of the project was originally developed in the early 1930s as a rainwater retention basin to serve the Tempelhof airfield and the adjacent avenues. And when the airport was shut down in 2008, the whole area of the airport was turned into a huge park. And the architects of Ramblabor, they opened this area of this retention basin to the public and made it a meeting place for students, experts, and citizens interested in urban development. For 6 months, it became a place of a transdisciplinary exchange with more than 20 seminar groups, with more than 40 workshops and numerous discussions, presentations, and lectures. It was a laboratory and a platform for new forms of urban practice. So, of course, the first thing that had to be done were that students and their teachers collaborated in building this campus. You see these different buildings here. So they were all built by the students and the teachers. So these are all learning spaces for workshops, an auditorium, a laboratory tower, for experimental water filtration systems, a kitchen, a bar, and of course toilets. And this was a very successful project where really new forms of sharing knowledge were tried out and experienced. And it was so successful that the project that was supposed to be a temporary project for 6 months was then taken over by a couple of people that made it a permanent project. So until today, there are exhibitions happening, lectures happening, and it was given over to an association that was founded in order to run this place. So yeah, this was a very fast run through what we showed in the exhibition, and yeah, I thank you for your attention, and I hope you enjoyed, and I'm curious to know what you think about it, and curious to hear your questions. Thank you.
Thank you, Ilka. Thank you so much.